Hello everyone, my name is Benjamin Debucher and I'm the Head of Events Program for JEC Group. Thank you for joining us today. Today's webinar is Automotive Composites Made Possible with Huntsman, polyurethane and epoxy innovations. As you all know, the automotive industry faces more and more technical challenges when it comes to composite materials. The industry is therefore looking for ways to optimize the production of complex composite parts for automotive application without overlooking weight, safety, and performance, which are essential. Today, we will be hearing from Huntsman automotive and composites experts who will share how their latest polyurethane and epoxy resins help meet those technical challenges faced by car manufacturers in specific automotive applications such as battery housings, interior panels, and pressure vessels. So, are you looking for ways to optimize your production of complex composite parts for your automotive applications? Are weight, safety, and performance important to your composite part production? Are you looking for solutions for your battery housings, interior structures, and pressure vessels? We will answer these questions in the next 60 minutes. Quick reminder for our audience. So as usual, we'll be taking questions at the end of this webinar, and you can ask your question in the question tab here on the right of the screen, and I will be reminding you again during the webinar. You have also the possibility to upvote the questions from other participants. During the webinar, at the end of each section of the presentation, you will be also invited to take part by answering 3 poll questions. To maximize the experience of the webinar, as usual, I recommend you to be connected through cable wire rather than Wi-Fi. In any case, this webinar is being recorded, so you will be able to view the entire program later on geccomposites.tv. But let me first open the floor to Giulia Gramelinu, Operational Marketing Manager for Advanced Material at Huntsman. Giulia, welcome on stage.
Thank you, Benjamin, and good afternoon to everyone. I'm Giulia, and I'm very glad to welcome you as well to this Huntsman webinar. I will briefly introduce the Huntsman company to explain you who we are and how we have built our strong knowledge and expertise in the automotive composites applications. Then I will focus on some key applications where both polyurethanes and epoxy resins have a major role to play, such as battery housing, car interior panels, and pressure vessels. You will basically see how our Huntsman product offering and overall support is able to answer your needs for these specific applications. And finally, as Benjamin said, we will open up for a question sessions. So feel free to ask all the questions you want to go to. To go into the details of the 3 mentioned applications and then give you the insights in the subjects, we have today our composite experts in the field. So please let me introduce them to you first. So our first speaker is Sebastian Pantou. He is our new business development manager for composites. Our second speaker is Bart van Grimde, and he is our technical manager for composites. The third speaker from our side is Hubert Breitberger, and he is automotive composite product manager for Huntsman. So before giving the word to our 3 speakers, let's start with a brief introduction of the Huntsman company. Huntsman is a global company which was founded by John Huntsman more or less 50 years ago. And today, Huntsman Corporation is a publicly traded global manufacturer and marketer of specialty chemicals. In 2020, our revenues were approximately $6 billion, and our chemical products number in the thousands. We sell worldwide to manufacturers serving a broad and diverse range of markets, both consumers and industrial ones. We operate more than 70 manufacturing sites. We have R&D and operation facilities in more or less 30 countries, and we employees at Huntsman are more or less 9,000 all over the globe. And basically, no matter where over the globe we are at Huntsman, for all of us, sustainability is a main driver for our daily work. Here we are acting on 3 different pillars to improve the sustainable character of our solutions. So all our new developments, for example, are SVH-free as well as CMR-free. So it means that basically they are not containing substances of very high concern, nor substances classified as cancerogenic, mutagenic, or reprotox. Also, we proactively replace, for example, all the entire bisphenol A containing product range, replacing these by formulations with a bisphenol A3 equivalent. Our second pillar in this sustainability focus is the use of bio-based and renewable components for the resin side as well as for the hardener formulations. And here, for example, we employ epichlorohydrin coming from vegetal sources. And our third pillar is a rather longer vision approach, which is targeting to limit our carbon footprint by the reduction of energy consumption, as well as the management of the waste and the water, which we employ at our facilities. So this sustainability approach in mind, and with over 60 years of experience in developing composites resin technology, at Huntsman we can offer a broad range of composite solutions in order to reduce the weight, to enhance the performance, to improve the safety, and to optimize the process for the automotive industry. You will see in the upcoming slides how our Araldite, Rimline, and Vitrox solutions will help you overcome most of the challenges imposed to composites introduction in automotive, thanks to their specific features. We will indeed demonstrate the benefits of using our Huntsman solutions to face the challenges in the automotive segment, and we will focus on 3 different applications. For the battery housing, we will see how Huntsman solutions are enabling us to achieve significant weight reduction with designs that is meeting major safety, mechanical, and thermal requirements. Then for the interior structures, we will get demonstrated how Huntsman solutions can extend the design possibilities, boosting productivity, reducing weight, and retaining the mechanical integrity with composite spray molding technologies. And finally, for the pressure vessels, we will learn how to realize highly demanding tanks designs thanks to the Huntsman resins supported by custom simulation for a faster and more cost-effective mass production. So now, Sebastian, the floor is yours.
Thank you, Julia, and good afternoon, everybody. So this first application deals with electric vehicles. As you know well already, electric vehicles are currently booming, and the battery housing is a fast-growing application. So it catches a lot of interest, especially in the composite industry. Of course, it's not new. There are already different designs developed by OEMs and tiers. Various materials can be used, such as steel, aluminum, different composite materials, such as thermoplastics, thermosettings, with short fibers, long fibers. We can see also multi-material designs being used. So in this section, we are going to focus on long fiber reinforced composites. And our solutions have mainly 2 objectives. On the one hand is the weight saving, and on the other hand, the integration of additional functions which are required to protect the battery cells, and which means actually to ensure safety. So what do we offer? We have basically 3 types of solutions for manufacturing battery casing. The first one is Araldite epoxy resin systems. The second one is the Vitrox polyurethane resin systems. And the third one, the Rimline foam cores. So together with our customers, we have successfully demonstrated with those solutions that we can lead to weight reductions of the battery housing up to 40% compared to metal designs. So weight saving is, of course, an important point, an important factor for the adoption of composites for this such application, but it's also essential to focus on the primary function, which is the protection of the battery cells from various environmental conditions, impact, crashes, fire exposure. So basically, a battery case needs to be tested according to OEM standards, or even according to the Chinese GBT standard, which is actually the main reference right now on the market. It gives a frame to the tests to be performed on the final parts. It describes, for example, a fire pan test that can be challenging from the material point of view. So when we translate those requirements to the materials, to the composite material, and also to the resin systems, it means that we need to bring a specific fire resistance. This is the first point. The second point is structural properties are essential, because we are here talking about primary structures, structural parts, so high thermomechanical properties are required. Third point is it's still an automotive application, so of course we need high productivity, and then at the end we need also to be compatible with different additional functions like EMI shielding or integration of cooling systems directly into the composite design. So in order to satisfy the requirements for safety and productivity, we've been working with our customers on 3 different concepts. So the concept number 1 on the left-hand side here is, let's say, the easygoing concept, because we offer, in this case, a fire-resistant resin system. You can use whatever type of fiber you need, and you will get the fire resistance needed in various processes, such as RTM and wet compression molding. The concept number 2 in the middle is more oriented on mass production. In this case, the intumescent function or the fire resistance strategy is up to the final customer. And there we are supplying a resin system which is compatible with the mass production. So it can be Araldite epoxy systems or Vitrox polyurethane systems, which are fast cure. And the third concept, so it's a sandwich construction here, which targets higher bending and torsional stiffness, and can bring also higher thermal insulation. So here we offer some concept with core materials. So let's have a look more in details in concept number 1. So concept number 1, as I was mentioning, it's intrinsic fire-resistant resin system to be used directly. So it's unfilled. We don't have any fillers inside. We don't have any free halogens. And still we match the fire resistance. So on coupon level, we target the UL94 tests. And so you can see here on this table that the V0 rating, which is the highest fire protection, is reached in most of the configurations. With basically 2 generations of systems. So the first generation system is offering very high thermal resistance, TG above 250 Celsius. And in this case, we need a post-cure. You need to post-cure those systems. And this can be a limitation, so we designed a second generation system here to improve this point, so still having the fire resistance, but now dropping down the cure cycle time to 3 to 5 minutes. So first generation system is already qualified in supercar vehicles, so we are already manufacturing battery cases. And the second generation, so the new generation here, is qualified also in China in buses applications, so for the battery housing of buses. Then having a look at concept number 2, together with Araldite epoxy systems. So as I mentioned, this second concept is more oriented on the mass production. And in this case, the customer is going to select the fire resistance strategy. So it means they can bring some flame retardant fillers or additives directly in the resin system by themselves. They can put fire-resistant veils or fire-resistant textiles on the top of the laminate before the injection or before pressing the parts. And then we are delivering some fast cure systems, which are structural systems with typical cure times between 30 seconds and 2 minutes without any post-cure. Yeah. So and depending on the process that you select and the cure temperatures. So now I will give the word to Bart, who is going to talk a little bit more about this concept number 2 together with the polyurethane solutions.
Bart, you are mute.
Thank you, Benjamin. So welcome everybody. So let's indeed continue to analyze this second concept. So Huntsman can also provide Vitrox polyurethane-based solutions for battery housings, where this flame retardant device is applied on top of the surface. So the Vitrox Rtm pure resin process benefits are mainly its low viscosity and its tunable injection time. And these attributes make it suitable to produce large parts at quite high fiber volume fractions for ultimate structural capacity. With the built-in snap cure catalysis of Vitrox, you only need a short cure time after the injection, so you can demold your parts very fast. And together with the integrated internal mold release, the snap cure of this patented system makes your production really mass production capable. So these polyurethanes typically result in very damage resistant parts, and that is thanks to the high resin ductility and the high toughness of polyurethanes, and this in combination with a very strong fiber matrix adhesion. So the Vitrox Rtm snap cure systems are designed with a glass temperature of about 110 to 130 degrees centigrades, and so they have the thermal resistance that is required for use in semi-structural or structural applications like we discuss here today. So let's move on. So third concept is where we insert a polyurethane core material in between two rigid face sheets with as resin any of the epoxy or polyurethane systems which we presented previously. And so a sandwich panel is created with a very high bending and torsional stiffness, and this creates a very efficient structure, as you probably know. So the Rimline FC foam core is molded directly into the final shape by injecting or pouring it into the closed mold. And so you can mold both thin, thick, large, and complex shapes with this type of material. The formulation has good flow characteristics, and hence the cavity filling of the mold is excellent, even at a low limited foaming pressure. These systems can be molded in a large density range. Typically, we go between 150 and 300 gram per liter, and the resin characteristics can be tuned to meet the customer manufacturing needs. The productivity of these systems is quite high, thanks to the fast cure and also thanks to low tool cleaning needs with the Rimline FC formulations. So once you demold it, the core is ready to be overmolded. And this core is a great option to be used with the wet compression process or the resin transfer molding process, as it can withstand the typical pressures and temperatures that you see with these processes. The core can develop a good adhesion with the sandwich skin, so you have a good structural part. So in short, Rimline foam cores possess an outstanding property balance for a reliable process performance in these type of applications. Let me introduce you to another concept. So it's a variant of the third concept. So also a sandwich design, but now with a composite spray molding process, also called CSM, where we use the Vitrox AC resin. So here you start with a flat thermoplastic core material sheet, typically a polycarbonate honeycomb, over which you drape glass or carbon fiber reinforcement. And then you spray the Vitrox AC resin over it, first one side, then the other side. And then you move this stack, the sprayed stack, into your 130-degree C-heated mold to compression mold it. The Vitrox AC resins have a tunable resin reactivity, which make it possible to adapt to a wide range of molding conditions. You can mold quite complex geometries with this technique, as the core has a good thermoformability and stretchability. And like in the previous concept, the sandwich design results in parts with very high stiffness to weight ratios. So today, this process is mostly used to mass produce automotive float floors. Hubert will tell you more about that a little bit later. But we believe it also has a chance to become a process of choice in battery applications, as it offers the possibility to mold these complex shapes without preforming, to integrate multiple parts into one large part, and all of this at a limited investment cost, because the pressure in your mold is quite low, which also results in a low tooling cost. So this covers the section on the battery housings, and let's continue.
Thank you, Bart. Before going ahead, I have a general question about battery boxes. Today, those battery boxes are mostly built in metal or aluminum. What are the benefits composite materials could bring to this application?
Yeah. First of all, we believe that the weight saving is quite significant, which can be achieved with composites. We believe it is between 25 and 40%, which is quite a lot when you consider that these components can weigh 100 kilograms. Secondly, the thermal behavior is very different between a metal and a composite, and so it can offer advantages in thermal insulation, which can increase, for example, the battery efficiency. And thirdly, there's a large difference in the process and design aspects between composites and metals. And so the designers, they can explore the opportunities of composites for part function integration, multi-material use, and also design for assembly techniques which are not there with metals.
Thank you for your answer, Bart. Just would like to remind the audience that you can also ask your question to the experts in the question tab on the right of the screen, and we'll try to answer as many as possible of your questions at the end of the presentation. But before continuing with the presentation, and in order to close that section about battery boxes, I would like to launch the first poll to get your views on the main drivers to adopt composites in battery designs. So to answer the poll, you need to go in the poll sections next to the chat and the question tab. And here is the poll. So what do you consider as main driver to adopt composites in future battery designs? So you can have multiple choice to answer. So lightweight, safety, mechanical performance, design freedom, thermal insulation, easy to manufacture, or costs. Don't hesitate to vote right now for a few seconds, and we'll analyze the results. Okay, so after a few seconds, we can see that most of you are answering lightweight, about 30%, then followed by safety, design freedom, and costs for about 15% each. Thanks very much for participating in the poll. Okay, let's continue now and discover how polyurethane can help to create interior structure for your car application. Hubert, the floor is yours.
Thanks, Benjamin. And good afternoon to everyone. Bart already referred to the technology composite spray molding. So let's talk about it and its use for lightweight interior structures. So when opening the car trunk, you immediately will find a typical part, the load floor, which is made in the composite spray technology. As in the trunk, heavy loads are transported. This part needs to be very stiff. So usually, at least I do, just misuse sometimes my trunk by loading just heavy stuff in there. So it needs to be really stiff. Load floors are becoming more and more complex in their design, which makes the production more difficult as well. At the same time, productivity must be affordable to keep the part cost low. Low cleaning needs, low waste, and low rework are taken for granted. And these challenges in complex load floor design and production do require the resin to having a broad spray window, but keeping the cure time short at the same time. For a clean production, the resin is not allowed to drip on the one side, but on the other side, edge filling capabilities need to be very good to have a high part quality, especially in the edges.
Hubert, sorry to interrupt. I have a quick question for you. We do see adoption for structure in interiors applications. Do you see use of this technology for exterior as well?
Yes, indeed. This process becomes suitable for the exterior use and as well for more structural applications. Like you can see in the pictures in the middle, this the roof module of this off-road car, or a body panel or body part for a sports car in the composite spray molding technology. And this has been done by changing, for example, or using a carbon fiber, recycled carbon fiber mats, and instead of paper honeycomb, for example, polycarbonate honeycomb cores.
Thank you, Hubert, for your answer.
So let's continue with the molding process itself and the materials used for that. I'm sure many of you are familiar with the process itself of how to manufacture these, which is basically spraying a pure resin on both sides of a paper honeycomb core, which is covered with glass fiber mats. Finally, this is then transferred to the press and for the subsequent molding process on the compression. The Huntsman team is ready for you to discuss this more in detail, and we are inviting you into our technology center in Everberg, as long as COVID is allowing that for sure, for a live demonstration. That's to show the advantages of and how the process works. Now I would like to talk a bit more about the pure resin itself, and specifically about the Huntsman polyurethane solutions. Our inline H2 Plus composite spray molding resins do offer design freedom thanks to its excellent edge filling capabilities, with the reduced need of extra edge spraying. The cure profile is suitable for simple, but as well very complex parts with deep draws and high paper compression. Even though the spray time can be done up to 100 seconds to operate multi-cavity or large tools, the cure time is 35 seconds for simple or 60 seconds for very complex parts only. The better productivity combined at the same time with a cleaner production makes the Rimline H2 Plus resins the perfect fit for your production. The integrated mold release allows a high number of moldings without any tool cleaning in between. As the resin is forming a strong paste when sprayed, there is no dripping to the floor, and as well there is no wasted PU spray like an overspray. The Rimline H2 Plus resins do show spot-on properties. Its high mechanical integrity can be found in the high bending strength and the high stiffness, but as well in the high skin-to-core tensile adhesion strength. Changes in process, for example, a demold time or in spray time, in spray density, they have only little effect on the final part properties, but they do make do allow the resin to be used in easy and in a wide process window. Sorry. A good carpet adhesion strength without extra surface preparation reduces the number of production steps and enhances the final part durability. Gramelinu Plus is built for interiors, so low volatile emissions, low windscreen fogging, and low odor are key for such kind of applications. As Bart already illustrated in the battery example, the opportunity to move this technology from an interior semi-structural application to more structural application, you can think of just keep the process as it is, but change the paper honeycomb by polycarbonate honeycomb cores, or the glass mats by glass non-trim fabrics, or even recycled carbon. So we are looking forward to help execute your ideas. But before, I would like to hand over to Benjamin to launch a second poll to close this interior structure applications topic. Thank you.
Thank you, Hubert. So we'll launch the second poll. So again, please use the poll tab on the right of the screen, just next to the question tab. You have 10 seconds to answer the questions, and we'll see the results. So here is the poll and the questions. So what would be the next application for composite spray molding? So instrument panels, body panels, seat shells, Class A parts, truck floors, under protection panels, battery boxes, or none of them. Please submit your vote. And here is the tendency. So mainly truck floors for about 20% of the audience, followed by battery boxes, body panels, battery boxes for around 20%. Thanks very much again for participating in this second poll. Let's now continue with Sébastien, who will talk you through the field of pressure vessels. Sébastien, over to you.
Thank you, Benjamin. So this last part about pressure vessels. So the market of fuel cell vehicles is expected to grow significantly by 2030, basically in the next decade. It concerns not only heavy duty, but also light duty vehicles. Here, what I would like to give you here, it's an overview of how our epoxy solutions can support the pressure industry in this growth and in this journey. Our main targets are, on one side, of course, to meet safety requirements. It's to say to help our customers to build reliable pressure vessels. And on the other side, to focus on productivity to support the increasing demand. So on the next slide, so here, Huntsman is a global supplier of epoxy solutions for pressure vessels already. So we are qualified for the serial production of CNG pressure vessels for more than 10 years. In the last years, we have been focusing more on the qualifications into hydrogen storage solutions and applications. So let's start with the productivity. So for us, it's very important to make the connection between the chemistry and the manufacturing process. So we have not been only working on the resin systems, but also on processes, and not exclusively on the conventional or standard wet filament winding process, because we think that there are some alternatives that have a bright future, like the RTM or the toe preg winding process. So now, regarding safety, the first point for us was to understand the technical challenges. So the service pressure are increasing, and there are some strict regulations like the GTR number 13, which demand not only pressure testing, but also impact resistance, chemical resistance. They ask for various testing temperatures, various humidity environments, pressure cycling tests. So it's very complex, and it was very important to understand all those parameters to establish our portfolio of products. And at the end of the day, we end up with a portfolio with the special features like the fast processing, being cost effective, to bring some specific thermomechanical properties, and of course ensure durability properties. So let's see first the wet filament winding. So of course this is the main manufacturing process for pressure vessels, and it will stay like this for quite a long time still. But because it's a well-established technology, it's an optimized process. The equipments are also optimized. We know also what are the limitations, the winding speed, for example. And still we keep developing some products in this area to support the hydrogen industry. So we have reported here, it's not an exhaustive list, but 3 different resin systems in this table. And so the common points of them is that they have a long pot life for making the process quite easy. They have a low viscosity for a fast and good impregnation of the toe, the fiber toes. Yeah. Then moving to the next one, going into the details of RTM. So first of all, a question you may have is, how does it work? So basically the fibers are braided over a liner, which can be a thermoplastic liner. And then this type of preform is placed into a closed tool, and we inject the resin and the pressure. So it can be low pressure RTM or high pressure RTM. Why using the RTM concept? First of all, because it's a clean process. Secondly, because it allows fast injections and fast cure times. It provides a significant improvement of productivity versus the wet filament winding process. Due to these particularities of this process, of course, it's ideal for smaller geometries, so more for light-duty vehicles, for example. We have one resin system reported here, which provides very short cure times, or quite short cure time for such application, 20 minutes into the mold. We have also a very nice balance between the injection time and the cure time, and it provides also good hot, wet, and thermomechanical performance. Then for the third type of manufacturing process, the toe preg winding. So toe preg winding captures a lot of interest on the market nowadays for several reasons. It's clean. It's also very fast, so it's fast in winding, up to 5 meters per second. We can use fast cure resin systems, and it's pretty reliable, very consistent, and offers a very good quality control. So it's appreciated in the automotive industry and by the quality people. So what's our concept? Huntsman is not a toe preg manufacturer, but we offer the resin systems to be used by the toe preg manufacturers or to be used directly by the customers who would like to manufacture their own toe preg in-house. So this is important to have this in mind. And I think with this concept, we solve a lot of problems. And we give a certain freedom to customers to select their fibers, their resin grade, the resin, select the right resin content, also to avoid any problems of cold storage or cold transportations. So we have basically 2 resin solutions here reported. One is focusing more on the high TG, and the second one more on the mechanical properties and very high fracture toughness. What we can say is that for those systems, we have an outlife which is up to 1 month at room temperature. The concept that we have is about a very low tack to allow fast bobbin and winding and facilitate winding operations of the pressure vessels.
Sebastian, sorry to interrupt. I have a quick question for you before going ahead. Are the processes you just presented to us, are they future concepts, or do you have already existing applications?
So for the filament winding application, it looks pretty clear. We are already supplying multiple customers, so no questions about this. So now for emerging hydrogen storage applications, we are intensively working with different players, with OEMs, with tiers globally, specifically in Japan, South Korea, China, now more and more in Europe and US. For RTM and Toughness concepts, we are already under qualification, and if we're not already supplying, actually we are in the phase that we are qualifying and developing the application. So it's already a reality, actually.
Thank you, Sebastian, for your answer. And again, I remind the audience that you can ask your question in the question tab on the right of the screen. Thanks, Sebastian. Over to you.
So I talked a lot about processes. Let's give some few words about safety, which is at the end of the day linked to the performance of the fibers, performance of the resin system. So when we develop a resin system for pressure vessels, we pay attention to the following characteristics. So first of all, the glass transition temperature, so the thermal resistance to withstand service temperatures in dry and wet conditions. We pay attention to the mechanical strengths and elongation of break, which will have an influence on the ultimate burst pressure and the mechanical behavior of the pressure vessel. And at the end, or the third point, is also to pay attention to the fracture toughness, which helps to bring impact resistance and also increase the fatigue life of the part. So on this graph here, you can see the strength versus fracture toughness, and all bullet point is a resin system that was introduced before. So you can see basically we have two different groups. One group with high strength and regular, let's say, standard fracture toughness. And on the other side, we have reasonable strength together with very high fracture toughness. So actually, there are different requests in the market. Some people do not need to have extra impact resistance, because they have other concepts to protect their pressure vessels. So we supply them with the regular type of fracture toughness. And then some of them, they ask for the specific impact resistance or extended fatigue life for safety coefficient reasons. And there we have the second group of products. So we have really a full comprehensive line of products to bring some solutions to this pressure vessel industry. So now I think we are going to the third poll. We would like to have your views also on this pressure vessels activity. So maybe Benjamin, you can introduce the question.
Thank you, Sebastian. Indeed, let's launch our last poll to close this section and get your views on the trends for future adoption for automotive pressure vessels. So again, you go in the poll section and you have some seconds to vote. So here is the questions. What are the trends you see to find adoption in future pressure vessel mass production? So is it liquid hydrogen storage, cryo-compressed hydrogen storage, thermoplastics, top-reg grinding, or others? And the results, so it's moving fast, but most of the people, for 30%, are thinking about liquid hydrogen storage, followed by top-reg grinding, about 25%, and then thermoplastics with 20%. Thanks again for answering the question. I'm now going to let Julia tell you more about the service and support offered from Huntsman together with their chemical solution. Julia, the floor is yours.
So thank you again, Benjamin. So as we mentioned before, at Huntsman, we consider ourselves not only as a chemical supplier, but really as a solution provider. So our solutions are always going hand in hand with dedicated customer support. For us, support has indeed to be provided along the entire lifetime of a product. So we start with extensive and reliable testing, which is mandatory for developing our solutions. And then for sure, the same testing capabilities are needed for the final customer validation and qualification. And this is why our testing capabilities and our certified testing laboratories enable us to run the most relevant tests which are needed in the three kinds of the applications you have been through today. As well, testing is essential for generating data on which we can rely for the simulations. So indeed, in order to help reducing the development time at Huntsman, we offer a highly professional and efficient technical support, also in the form of simulation capabilities. And I will come back to this in the next slide. Then next to the testing and the simulation I just said, there is a third very important topic for us, and we strongly indeed focus also on supporting our customers on the processing side. So we all know basically that a composite material gets created during the process itself, and hence it's a key part of the final material and the product itself. So processing is absolutely key. And this is why we provide extensive processing support from experienced engineers. And this we can provide starting from our well-equipped laboratories in Switzerland as well as in Belgium, as well as normally, so once COVID will hopefully allow it again, directly on site at your facilities in the real conditions. I would just very briefly focus back on our simulation capabilities, as we have been pioneers in introducing these for our composite solutions. And we can now say that we have a strong experience which enables us to have accurate results. So indeed, our simulation experts are able to predict the outcome with 90% success rate, which is extremely gratifying for us. So the first advantage we can extract from our simulation is to increase the process safety. So we can control and avoid exothermic peaks. We can reduce and avoid the internal stresses or damage. Sebastian mentioned before that very often, or in all cases, pressure vessels have inliners, which are mostly out of thermoplastic materials. And we know that we have to be careful not to have temperature peaks in the process, which might damage them. So this was the first advantage. So we see also a second advantage in using simulation, and this is linked to reducing the development times by selecting the right system as well as the boundary condition from scratch, from the very initial. So it means that if we have to set the mold temperature, or if we have to understand, do we need to heat a preform, or do we need to have the resin and the hardener put at specific temperatures before injection or use, we can define these initial processing parameters based on the specific customer designs. And the third and main benefit is also, of course, to increase productivity. So with the cure simulation, we can understand and optimize the cure cycle, considering indeed, again, various parameters such as the mold nature, characteristic, or other important features. So in summary, for us, the simulation tools and data which we have generated over several years really helps us selecting the right system for your application and your manufacturing conditions, allowing to optimize the processing parameters and consequently, basically, to reduce the production costs. So to sum up, we have learned today how Huntsman polyurethane and epoxy innovations help you to solve your automotive challenges with regards to the battery housings, to the interior structures, and to the pressure vessels. So our composite resins solutions are able to reduce the weight, enable you to enhance the performance, improve the safety, and optimize the process. So that's all. I hope you enjoyed the presentation, and thanks a lot for your participation. So Benjamin, the floor is back to you.
Thank you very much, Julia, Sebastian, Bart, and Hubert for this great presentation. It's now time to open the floor for questions, and I see that we already have a few in the question tab, so thank you very much for this. You can continue to ask your questions. So let's start with the first question. I see that some of the experts already answered some of the questions. Here is the first one from Murali Reddy, who is asking, do you have any data on cold temperature performance of Araldite? based composite, can they be used to make battery enclosure for colder region considering their TG? So I would put this question to Sébastien and Bart, I think.
Yeah, so for this epoxy system, basically, we have already some qualifications. So we have one qualification with the concept number 2, which was introduced for the battery enclosure. So it means that we have already generated some data also at various temperatures. Low temperature, I think, was minus 40 Celsius, something like this. Of course, we like to provide the data, mechanical data, with a specific fiber layup. But we should have already something available if it's of interest for you.
Thank you, Sébastien. Let's move to the next question from Dominique Brandsetter, who is asking which kind of material is used for the fire-resistant surface. So I think again it's for Bart and Sébastien.
So yeah, basically, I think this question is referring to the concept number 2 we have with the mass production system together with the intumescent function on the surface. So we know that there are some suppliers, textile suppliers, that are providing some fire-resistant textiles. So they have some additives on top of this, and you just need to use few layers on the top of your laminates to bring the fire resistance. Yeah, so for example, you can get such kind of textile from the companies like Certex or TFP in the UK.
There's also coatings in development which can be applied after production of the part, amongst others by Huntsman.
Thank you, Bart and Sébastien. Let's move to the next question from Abhishek Shetter, who is asking how thin cavities can be for the resin to flow well in them. To tell you the truth, I'm not sure who can answer this one. So if one of you is at least to answer, you can go.
You have to consider that the fibers between which the resin flows are only 20 micron or 7 micron thick, so the gaps are really small in which these resins flow. So with typical viscosities of about 100 millipascal seconds, these resins flow really into the tiniest cavities. Yeah.
Thank you, Bart. Next question from Virginia. You are mentioning high stiffness and fiber resin adhesion. Can you give some key material property values for these material properties of the composites? Maybe Julia? No, Sébastien?
Yeah, so I think for this question, it's a very specific one. So we should take some clear examples and then check if we have already the material cards or material properties available for a combination of fiber and a specific resin which is already selected.
Okay, thanks, Sébastien. So let's move to the next one from Johannes. How do you increase the impact performance of the battery housing structure? And is there a notable difference between Thermoset and Thermoplastics? What about the use of woven fabrics in the surface? So different questions in one question, but I will put this to Bart and Sébastien.
So yeah, first of all, the design of the battery housing is very important. So especially for everything related to impact and crash, there are some stiffening elements. You can even think about some pultruded profiles to be integrated in the structure to bring the very specific impact resistance. Then going down to the material, of course, impact performance can be brought by the matrix. So depending on the matrix that we are using, we have a different level of impact performance. Difference between thermosets and thermoplastics. Yes, it's a good point. Aside the main difference in the processing, of course, thermoplastics are behaving quite well also in impact performance. But I will maybe let Bart comment a little bit about the polyurethane performance in terms of impact versus thermoplastics, maybe.
Yeah. Well, the thermoplastics. Yeah, there's a very large range of them, and indeed they have excellent toughness values. But we believe the impact performance is something which is very much related to the component design and notably the thickness of the part. And so it's not always sure that with the toughest resin selection you really get a much better property of your after impact behavior, let's say. And as you correctly state, also by changing the type of reinforcement, you can already change your impact behavior quite significantly. So it's a thing which needs to be traded off in the particular condition in which you act, and cannot be generally stated, I would say.
Thank you, Bart and Sébastien. Okay, let's move to another question from Naile, who wants to know if the resins are fire resistant or retardant.
So as described in the concept number 1, so the resin are fire resistant. So basically they are self-extinguishing. And according to the V0, it means after, so they are burning less than 10 seconds after flame exposure. So they are really protecting the battery cells during the real test. Because the real test is actually a pan, and you set up some fires with some fuels, and you let it burn for a few minutes, and then it needs to keep the integrity, so it needs to be fire resistant somehow. And so this is what we bring with those kind of concepts.
Thank you, Sébastien. Next question from Andreas Klinger. Hello, Andreas. How about the permeation resistance of the presented resin system against hydrogen?
That's a very interesting question related to type 5 pressure vessels. We are currently investigating in this. So right now, most of the developments are type 3 or type 4. So in type 4, we don't have the same question because we have the liner ensuring somehow the big part of the permeation. For the epoxy resins and the permeation against H2. So this is still some studies ongoing. Yeah. But really interesting questions. I think there is a background behind, and would be interested in discussing more in details about that.
Andreas is a PhD student from Kaiserslautern University. Okay, let's move to the next one. Virginia is asking, what are the fiber volume fraction you are getting for the resin spray system, interior application, and the RTM process for pressure vessels? So I think it's Sébastien again.
And maybe for the first one, it's Hubert. So for the resin spray systems, interiors, typically it's 50% in weight fraction. So it's about 30% in fiber volume. Because typically what you envisage there is to have a quite good filling of your edges of your part, and also you want to have a good adhesion with your honeycomb. And so that is why with the resin spray systems you act at a little bit lower fiber volume fraction. And so I will let Sébastien answer for the RTM process. You're silent, Sébastien.
We can't hear you very well, Sébastien. I don't know why.
Right now?
Yeah, it's better.
Okay, so for the RTM process and pressure vessels, so basically we're targeting around 60% fiber volume content, 60.
Okay, thank you for your answer. Let's move to the next one from Andreas Klinger again. How to select a resin system for pressure vessels? What defines the properties? Is it more the environment they are exposed to? Sebastian again.
So selection of the resins comes from also the design. So it goes together with the design because there are some design criterions, and most of the times our customers knows already what kind of properties they need, at least for the composite material, and then we translate this to the resin system, and we make the characterizations to ensure that we have the right properties. What defines the properties? Of course, it's the one is the service pressure. So the design and safety coefficients are a little bit different if you consider a 300 bar or 700 bar pressure vessel. And then what is very important, and what I mentioned in the presentation, is the regulations for passenger vehicles with the GTR 13. We have some tests to pass on the real designs, and the environmental conditions are defined there. So even the humidity conditions, for example, exposure to saturation at 85 Celsius, 95% relative humidity for 4,000 of hours, and then being tested in fatigue. The service temperatures and environmental temperatures are defined into those standards.
Thank you, Sebastian. We can, I think, take maybe 2-3 more questions. This one comes from Vladimir. He's asking, in general, do you work or seem in the direction of nano additives implementation in the resin for system reinforcement, carbon nanotubes, multi-layer graphene, or other? No one wants to answer this one.
In the PU division, we are not working with carbon nanotubes.
So from our inside, we have acquired a company who is focusing, so Miralon, on carbon nanotechnologies. So we are looking into it. We already have also formulated adhesive system with these technologies. And we can for sure give you more insights. It's not only for composite resin system solution, where we also focus on, but also for adhesive technologies and other technologies at Huntsman. So happy to tackle it in a separate discussion, because it will open a complete new world for the Huntsman division.
Thank you, Julia. And Vladimir, you have the contact details of the polyurethane and advanced material team at Huntsman, so don't hesitate to drop an email. Next question from Virginia again, who is asking, what is the range of fiber reinforcement that you are mostly using for these automotive applications? So maybe the three of you could answer this.
I think for the composite spray molding technologies, the range is basically on chopped strand mats, range from low grammages up to quite heavy ones as well. So it's fully depending on the application you're after. But as well, if you then translate it into the exterior applications, that goes to non-crimp fabrics, from glass, but as well as to carbon. So I would say in these applications we are using the full range, as you could imagine.
For the RTM processes and with compression molding processes, as it's very structural applications, it's also often these non-crimp fabrics that are used. Either with glass, either with carbon. So depending on the design of parts and whether it's stiffness or strength driven.
Thank you, Bart. We are unfortunately running out of time, but be sure that we will come back to you if we didn't get the chance to answer your question. We'll get back to you by email. Thank you, everyone, again, for joining us, and thanks for your great questions. Don't hesitate to get in touch if you have any more questions. You have the contact details on screen of Huntsman team. The event has now come to an end, and we hope that you enjoyed the time with us and have learned something today. I would like to thank our 4 experts today, Julia Gramelinu and Sébastien Pantu from Huntsman Advanced Material, and Bart van Grimde and Hubert Weiberger from Huntsman Polyurethane. The webinar was recorded, and the link will be sent to you immediately with the possibility to download the presentation. And we will also send you a survey to capture your feedback about this webinar. We have another webinar next month on May 11th at 10 a.m. with Profol from Germany, and we'll discuss the transformation of performance composites into mass production. So it should be an interesting one once again. And you can get the information about it on Jack Group website, where you can, as usual, register for free. Thank you again very much to everybody, and we hope to see you again soon.
Thanks.
Bye-bye.
Bye.
Bye.
Thank you. Bye.